What if you could swim in Titan's lakes? Standing on the shore of one of Titan's vast lakes, you gaze out at a scene both alien and eerily familiar. A horizon shrouded in perpetual orange haze, a shoreline formed by frozen water ice and organic-rich dunes, and before you, a dark, liquid expanse stretching out, rippling in the frigid wind. Yet, these are not lakes as we know them on Earth, not filled with water, but with liquid methane and ethane. Hydrocarbon seas so cold and strange that even contemplating taking a swim sets the mind spinning with possibility and hazard. What would it be like, truly, to swan dive into Titan's lakes? What would you see, feel, and experience? To answer, we must set forth on a journey that spans physics, chemistry, biology, and imagination. A tale not merely of swimming, but of encountering a world that challenges every assumption we have about the rules of nature. First, let us orient ourselves on Titan, Saturn's largest moon. Titan is a world of paradox. With a diameter greater than Mercury and an atmosphere even thicker than Earth's, it holds the distinction of being the only moon in the solar system with a significant, planet-like atmosphere. But that air is neither breathable nor benign. It is mostly nitrogen, mixed with methane, ethane, and complex organic molecules. The temperature at the surface averages a bone-chilling -179 degrees Celsius, -290 degrees Fahrenheit. Water, the solvent of terrestrial life, is locked solid as granite here, while hydrocarbons, gaseous on balmy Earth, accumulate as clouds, drizzle as rain, and pool as lakes. NASA's Cassini spacecraft and its Huygens probe revealed this amazing truth. Titan's lakes and seas, concentrated mainly at the poles, are not mere puddles, but immense bodies of liquid nearly rivaling some of Earth's Great Lakes. Kraken Mare, the largest, spans over 1,000 kilometers wide, deep enough to swallow a small mountain. Its rivers snake through valleys carved by eons of methane rain, shaping a strange landscape both beautiful and unfamiliar. To envision a swim in this alien world, begin first with survival. How would a swimmer on Titan even approach the lakes? Suiting up would be more than prudent. It would be absolutely necessary. The atmosphere, though dense enough to provide a dreamy, muffled silence, contains no oxygen. The methane and nitrogen cocktail would not just asphyxiate you, but actively cause your lungs and body fluids to boil off in the weak atmospheric pressure, were you to expose your skin or open your helmet. The cold would instantly freeze any exposed tissue into something harder than steel. You would need a suit akin to a deep-sea diving bell, but even more advanced, thermally insulated, gas-tight, and pressurized to withstand the subtle but lethal vagaries of Titan's air. Suppose, through the technological genius of future explorers, you are thusly protected. Your suit shields you from the cold, supplies warm, breathable air, and covers every centimeter of your body. Now, let's step toward the lake. The ground crunches underfoot, a mixture of water ice and organic sludge. The air is thick, the light dim, filtered by the ever-present orange-hued haze. The shore ahead is sloping gently, the dark gleam of Titan's lake beckoning. You approach the water's edge, a misnomer, as this water is mostly liquid methane and ethane. How does this fluid differ from Earth's familiar H2O? The answer is profoundly. At Titan's temperature and pressure, methane and ethane are not gases or solids, but clear, colorless liquids. Dip a gloved hand in, and you'd find the liquid both more slippery and less viscous than water. The density is lower, a measure of 0.45 kilograms per liter for methane, compared to water's 1 kilogram per liter, which means that you, outfitted in your presumably heavy survival suit, might swim very differently. On Earth, the buoyancy provided by water allows you to float easily, but in methane, your suit might sink unnervingly fast, unless carefully designed for flotation. The sensation of entering the lake overwhelms your senses, even through layers of synthetic protection. The liquid is cold beyond comprehension, possibly freezing your suit's outer layers into brittle rigidity. Waves lap at your limbs, sluggish and slow. Gravity, just over 1/7 that of Earth's, means your body feels strangely light, But the lower buoyancy of methane compared to water balances things in a novel way. You float, but lower than you would at home. With every kick and stroke, you move forward, but each action must compensate for the fluid's characteristics. It is less resistant than water. You cut through it more easily, but have less leverage for pushing yourself ahead. In the gentle gravity, you can swim with broad, slow strokes. Time seems to stretch out. Each motion takes longer. Each flip or turn has more follow-through before you can change direction. The horizon around you is painted in surreal hues. Instead of the blue of a sunlit sea, there's the dim, reddish twilight suffusing everything. There are no birds, waves, or the distant sound of surf. Just silence, and the gentle knock of hydrocarbon waves against the shore. What would you see beneath the surface? Sunlight on Titan is weak, only about 1% of what reaches Earth, and much of it is filtered by the smoggy sky. The water, again, liquid methane, would be crystal clear, but not necessarily colorless. Absorbing certain wavelengths, it might give the underwater world a peculiar bluish or greenish tint. You might see your arms and legs move sluggishly, ghost-like in the dimness. Looking up, the sky would be an endless sheet of orange, refracted strangely by the lake's elusive surface tension. What's at the bottom? Titan's lakes are thought to be hundreds of meters deep, with silty beds formed not of ashy mud, but grains of organic molecules. Tholins, complex hydrocarbon precipitates that shower down from the atmosphere, painting the floors in dark, tar-like layers. You would not encounter fish, plants, or algae here. Titan's seas are sterile, as far as we know, lacking life as we understand it. Bubbles might occasionally rise from the lake bed, trapped nitrogen or ethane pockets burbling upward. If you brought a light with you, a necessity in the thick gloom, what strange sights might you illuminate? Only the endless layers of hydrocarbon mud, sometimes warped into fantastical shapes by long chemical reactions unique to Titan's climate. On rare occasions, you might glimpse the aftermath of a methane rainstorm, a thickened area where droplets, larger than any raindrops on Earth due to the low gravity, have splashed fresh material into the lake, leaving eddies and streaks that swirl and dissipate slowly. The hydrodynamics of swimming would be equally odd. Kicking off from the bottom, your leap would feel effortless, your body soaring far above what is possible on Earth, floating gently back down on the feeble gravity. But without significant buoyancy, you'd have to swim harder to keep afloat, balancing suit design and your own force of will. The mechanics of a simple breaststroke or freestyle would be subtly but persistently altered. The lake's surface, meanwhile, would behave in ways that defy expectation. On Earth, wind quickly whips up waves, but on Titan, with thick air and calm currents, the surface would generally be eerily smooth. Occasionally, dark ripples might form, but they move slowly. Titan's winds are gentle, and the viscosity and surface tension of the methane and ethane differ enough from water to dampen large waves. In the midst of this alien sea, silence would dominate, possibly the softest, most profound hush you've ever heard, broken only by the sound of your own breaths, strange acoustic echoes, and the movement of your body through the frigid wash. As you swim, your senses adapt to the silence, to the colors, and the unfamiliar feeling of your own body. Away from the shore, you would find yourself enveloped by a sense of solitude found nowhere else. There is no chatter of life, no glimmer of plants swaying beneath the surface, no darting shadows of fish. It's like flying through a dream, untethered from the world you know. And yet, for all its alien nature, there would be moments of haunting familiarity. The dance of ripples on the surface, the change in light as a rare break in the clouds lets a shaft of distant sun pierce through, the soft spray of droplets against your keratin armor, the echoes of swimming in a mountain lake on an autumn evening. The same physics underpins both worlds: gravity, fluid dynamics, light, and matter, all constants, all strangers, and yet intimately known. But what then of the risks? Beyond the practicalities of survival, suffocation, freezing, toxicity, there are hazards unique to this world. Titan's lakes, for all their seeming serenity, may not be as tranquil as they appear. The composition of each is in flux. Methane evaporates, is replenished by rain, and can be replaced by ethane and other compounds. Sudden rainstorms of liquid methane can pound the surface with immense silent drops, forming hydrocarbon waves silently racing across the surface. On rare occasions, volcanic activity, cryovolcanism, might churn up new compounds, releasing gases from the lakebed in eerily bubbling plumes. Suppose, however, you are lucky and encounter none of these cataclysms. What then might you ponder as you swim within this cosmic abyss? The mind cannot help but turn toward the metaphysical. You are surrounded by molecules whose very structure forms the foundation of life. Hydrocarbons, the building blocks of complex chemistry. On Earth, such molecules concentrate in crude oil, tar pits, and pockets deep beneath the ocean. Here, they take center stage, forming cycles of rain, evaporation, and renewal that echo Earth's water cycle, but are made strange by temperature and chemistry. Could life, in some wholly alien sense, exist in these lakes? Researchers have speculated that if there is life on Titan, it would be unrecognizably different. Instead of water as a solvent, it would use methane or ethane, meaning that the very basics of biochemistry would be flipped inside out. Living chemistry in Titan's lakes would rely on reactions that are sluggish and feeble at these frigid temperatures, and yet, perhaps, over titanic stretches of time. Even lethargic chemistry could birth something complex. As you float in the cold embrace of the alien sea, you might imagine tiny entities dissolving and interacting in the murk, not based on DNA or proteins, but some other cryptic code written in hydrocarbon chains. Perhaps one day, future explorers will return to Titan's lakes armed with laboratories, sensors, autonomous swimmers bristling with mass spectrometers, and microscopes more sensitive than anything on Earth. Perhaps they will find evidence of chemistry that hints at life, that dances tantalizingly near the edge of biology, or even crosses it. Until then, your swim remains a solitary communion, a single intelligent mind drifting in a world shaped by pressures and possibilities unimagined even a century ago. Embracing the strange, one might also contemplate the potential uses of these lakes. For explorers, the hydrocarbon seas are not just scientific curiosity, but also resource. Methane and ethane are powerful fuels back on Earth. To aliens, Titan might seem a paradise of energy waiting to be harnessed, its lakes a reservoir of riches. Floating installations could one day distill, process, and convert these resources, powering bases and equipment in the perpetual twilight. The prospect of water, too, frozen yet abundant, means oxygen and hydrogen could be generated through future technologies, closing a circle of sustainability for human presence on this distant world. Yet, to swim in Titan's lakes is to meet, viscerally, the reality that environments are not interchangeable. Water is not simply a solvent, but the very context of earthly life. In its absence, new rules emerge. The ease with which you take a breath, the familiar feel of water clinging to your skin, are gone, replaced by the clumsy encumbrance of life support systems, the hostility of toxic air, the silent certainty that, here, survival is always provisional, paid for by layers of ingenuity and vigilance. Leaving the water, you stagger back to the shore. The sensation is at once exhilarating and disquieting, a mixture of awe, humility, and longing. The ice crunches beneath your feet, the low gravity making every step feel like a leap in slow motion. A distant storm brews over the horizon, methane rain, falling in sheets miles wide, part of a hydrological cycle that has persisted for millions of years, its rhythms as ancient as Saturn's rings themselves. Resting on the shore, you gaze back at the inky expanse of Kraken Mare. You remember how, over centuries, philosophers have imagined what it would feel like to leave Earth behind, not just physically, but elementally. Truly, Titan is the fulfillment of that dream. Here, all things are reversed. Air thicker than water. Lakes not of water, but hydrocarbons. Solid ice as hard as rock, rivers as cold as empty space. It is a place where the familiar is made alien, and the alien, by virtue of shared physical laws, becomes unexpectedly familiar. What lessons does your swim teach you? Perhaps one is humility, a reminder that life as we know it is an arrangement as precarious as it is precious. that the universe is more strange and more various than any single world can express. Another is hope, for if the same laws of chemistry and physics allow for such a world as Titan, what else might they permit? Perhaps not only other environments for swimming, but other ways of being alive, other stories of existence waiting on icy moons or planets yet uncharted. In this sense, Titan's lakes are not only a site of scientific exploration, but of profound imagination. They challenge us to redefine the possible, to contemplate life and worldhood in terms larger and deeper than Earth alone. To swim in these lakes, even in mind, is to journey beyond mere geography into the heart of both cosmic strangeness and the enduring human desire to understand, to experience, and ultimately to connect. Much as the mariners of old gazed out at uncharted oceans, so must we, looking upon Titan's shrouded seas, remember that the spirit of exploration is not merely to seek the comfort of home, but to brave worlds in which home's certainties are nowhere to be found. In that bracing, frigid immersion, in hydrocarbon, in darkness, in profound silence, we find not alienation, but a renewed sense of belonging to a cosmos immeasurably vast, waiting for the touch of a human mind or a swimming hand. Ultimately, the question of swimming in Titan's lakes is not merely about risk or technology, but about yearning. It is about the urge to experience, firsthand, what no one else has known, to merge, even briefly, with the unimaginable, and to come away changed. It is about returning with new stories, new insights, and a sense of wonder that is as cold, deep, and abiding as the lakes themselves. And so, as we imagine the ripples left behind, the only trace of a human presence in the methane-black waters, we also imagine the next steps. New missions, new explorers, new dreams. Titan's lakes wait in the twilight, holding secrets older than history. And one day, perhaps, a swimmer will break the surface, a pioneer not only of space, but of the infinite possibility of existence itself.